Okay, today let's just answer a simple question. Why does calcium form a +2 ion? Well, like a lot of things in chemistry, it's a simple question that brings in a lot of background knowledge. So, let's first off define ion. Okay, so an ion is any charged particle. And a positive ion is a cation. And an anion is a negative ion. So, since we're looking at a +2 here, we can see that the calcium is forming a cation, and that squares, because metals usually tend to lose electrons. So metals lose electrons. Nonmetals gain electrons. So we've got that happening too. So metals lose electrons, nonmetals gain electrons. So if you lose electrons, you become a positive ion, and if you gain electrons, you become a negative ion. Now, when you think about the fact that the electron's charge is a -1, if you're gaining an extra negative charge, that would make sense that you would become a negative ion. If you're losing an electron, that would also make sense that you become a positive ion. So let's look at calcium in particular. So calcium is element number 20. So a neutral atom has 20 protons and 20 electrons, and I'm just going to go ahead, 1s2, 2s2, 2p6, that gets me 10, 3s2, I did a p there instead of an s, I was already thinking ahead, so it's going to look messy, but I know you guys won't mind too much. So that gets me to 2, 4, 6 is 10, and another 8 is 18. Oh, I need 4s2. So I get 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So if I do the orbital notation, 1s2, up, down, 2s2, up, down, 2p6, got to make 3 slots, up, 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 down, 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 3s2, up, down, 3p6, up, 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 down, 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 4s2, up, down. Okay? So the valence electrons are going to be here with the 4 because you got 1, 2, 2, 3, 3, 4. 4 is the largest number that we see. And since it's a 4, it has 2 valence electrons. Now, elements get stable when they have a full set of valence electrons. And a full set of valence electrons is 8. Okay? So calcium can go one of two directions here. It could either try to gain 6 and fill out its 4p, or it can just lose these two and go back and have this filled. Okay? So when calcium loses the 4s, both of those, its valence shell becomes the full 3p. And so, or 3s and 3p, but the third orbital. And so, boom, now it's stable. And all it had to do was lose 2. And they're always going to take the shortest path. If they have, it would take longer to gain 6 than it would be to lose 2. And so, calcium is always going to lose electrons. And that's how we come up with like these trends. You know, metals lose electrons because metals have less valence electrons than nonmetals. So when we do the count now, instead of having the original 20 electrons, we only have 18 electrons, okay? And so, since we are now have that noble gas configuration, since we have all 8 in our valence shell, but we have 20 positive charges and only 18 negative charges, leaving us a positive 2 charge. And that's why calcium forms a positive 2 ion.